Hello and welcome to this series in Mathematical Misconceptions. And today we're going to prove that a plus b fully squared does not equal a squared plus b squared. We're going to show this through algebraic construction as well as plugging in numbers. So if you're ready, let's dive in. The first thing that we're going to do is we're going to recognize that this square actually means something. It means that we take this quantity a plus b and multiply it by itself. In other words, you take that number and you multiply it by the same number. That is the definition of squaring at the end of the day. Let's go ahead and write this as multiplication. So we have a plus b times a plus b, which does not equal a squared plus b squared. Now, I bet about 95% of you watching this will know automatically that when you write this as multiplication, the next thing that you need to do is to FOIL. First, outer, inner, and last. And you're going to see that the right-hand side will appear, but an additional term will appear as well. And that's what we need to consider. What's missing? Let's go ahead and take the first. So a times a is a squared plus. And then we have a times b, which is ab. So we're going to go and put AB right here. The inner is B times A, which is the same as A times B. So if we add AB plus AB, we in fact get two of them. You can leave a little coefficient, save yourself a little bit of time. And finally, our last. So B times B is plus B squared. And this is not necessarily the same as A squared plus B squared. Now you'll see from here that there are two exceptions. If a is equal to 0, or if b is equal to 0, or even if both of them are equal to 0, this will in fact hold true. But what we're looking for is an identity. In other words, something that works for all real numbers. Whether that number is 5, 7, negative 49, etc. This has to work for all real numbers. So a squared plus 2ab plus b squared is in fact equal to a plus b all squared. And as I promised you before, we are going to in fact plug in numbers to verify that these two are the same and these two are not the same. So let's go ahead and do that. When we choose numbers to plug in, don't go for anything extravagant. Stick to simple numbers because it'll make things a lot easier for you, especially if you're trying to do this on a test and you're not sure what you're doing is correct. You want to choose easy numbers that'll make it easy to verify. Let's choose A to be 10, equals 10, and let's choose B to be 3. And you'll see why I chose 10 in just a minute. Now let's go ahead and start with our original quantity. So if A is 10 and B is 3, then it's going to be 10 plus 3, which is 13. We'll show that in the next step. 10 plus 3 fully squared does not equal 10 squared plus 3 squared. Now we're going to use order of operations on the left-hand side. So we have a set of parentheses. So 10 plus 3 is 13 squared. And now we can apply our squares on the right-hand side. Cannot equal 10 times 10 is 100. And then 3 times 3 is 9. And if you know your multiplication tables, or if you've done this enough times, you'll know that 13 times 13 is in fact 169, which does not equal 109. I bring this up because I've seen a lot of students that I've worked with, as well as those who take tests. They'll try to distribute the square into the A and B directly and try to bypass the plus. Can't do that, right? What we have to do is we have to rewrite this in the form of multiplication and then go ahead and FOIL things out. So let's show this one more way and we'll be done. Let's go ahead and verify that a plus b times a, or let's do a plus b fully squared is equal to this thing. So let's do it right here. So we have a plus b fully squared is actually a squared plus 2ab plus b squared. Let's use our same numbers. Let's let a equal 10 and b equal 3. Let's plug them in. Just plug them in at first. Try not to cheat and go over steps. Let's just do this the right way. 10 squared plus 2 times 10 times 3 plus 3 squared. We know the left-hand side is 13 squared. Right-hand side, we can just square things and do multiplication. 10 squared is 100, plus 2 times 3 is 6, times 10 is 60, and then 3 squared is 9. And so we already said that 13 squared is 169. And here we're just basically adding all these together. We have a 9 in the ones column, 6 in the tens column, and a 1 in the hundreds column, which gives us 169. So this in fact checks out. On a test, you may only want to do this once or twice just to verify if you're not sure. But when you're doing homework, I recommend you try several different numbers just to make sure that it's nice and consistent, because that's what's going to give you ownership at the end of the day. So this was mathematical misconceptions on a plus b all squared is not equal to a squared plus b squared. Now that you've seen this, I hope that you never do it again. If you have any questions, drop me a comment below and I'll respond to you. Otherwise, I'll see you in the next one. Thank you.